Okay, so we've got a couple of things that we're going to take care of here. Scale drawings. So first of all, our learning target for this lesson, I can determine the scale factor. Okay, and that's going to be a number. What do we multiply any value by on our scale drawing in order to replicate the actual item? And second, I can use the scale factor to determine the size of actual objects. Okay, so a couple of things, a couple of definitions here. Scale drawing, a proportional drawing of an object that makes it possible to represent objects accurately that are either too large or too small to draw at their actual size. So a reduction, a scale drawing that is smaller than the actual object. A great example of that is a building. Okay, a jet airplane. All kinds of different objects that we know are too large. Football field. We don't draw out a football field in real size. Okay, those are great examples of reductions. Enlargement. A scale drawing that is larger than the actual object. You may or may not have heard of nanotechnology. That means that we're talking about really, really small components. So inside of a computer, there are a whole bunch of chips. And those computer chips are hard to draw as small as they can actually make them. So you might have something like a computer chip. Okay, a molecule. Or an atom. In science class, you don't draw an atom the actual size because atoms are microscopic. So you have to draw them so that they look larger. And that would be an enlargement. So the scale is the ratio between two sets of measurements. Okay, so we're comparing two different sets of measurements. The ratio compares the measurements of the drawing to the measurements of the real objects. All dimensions are reduced or enlarged using the same scale. You can use the same units, like 1 inch is the same as 30 inches, so 1 inch on a drawing is the same as 30 inches on the actual object, or different units. 1 centimeter is the same as 1 meter. Okay, when you're dealing with maps, we can't use the same units because we're talking about miles instead of inches. When you look at a map, you're looking at inches. When you look at the actual ground that we are traveling, you're looking at miles. 1 centimeter to 1 meter, or 1 centimeter equals 1 meter. So 1 centimeter on the drawing is 1 meter on the real object. The scale is used to compute the actual dimensions. And blank can be used. What are they looking for there? Not sure. The scale is used to compute the actual dimensions. Anyhow, moving on. Example number 1. On a road map of Ohio, the distance from Cleveland to Pittsburgh is 4.5 centimeters. Well, obviously it's not 4.5 centimeters from Pittsburgh to Ohio. What is the actual distance between the cities if the map scale is 1.5 centimeters equals 30 miles? So here we set up our proportions, just like we did in the last section of work that we accomplished. So we know that 1.5 centimeters is the same as 30 miles. Well, we find the other mention of centimeters right here. And so that has to be in the same location in the second fraction. And what we're looking for is the actual distance. So we put in our variable. Okay, and now, ignoring the units for now, we cross multiply, just like we've been doing. And we take 1.5 times x, we get 1.5x. And then when we take 30 times 4.5, we get 135. And this is an equation like any other equation. We have 1.5 times x, so we have to undo that by dividing by 1.5. And we get x is equal to 90. So that means that it's 90 miles between. And I'm not going to write out the cities. We can see the cities here between Cleveland and Pittsburgh. Example number 2, on a road map with a scale of 1.5 inches equals 60 miles. Go back. The distance between Pittsburgh and Philadelphia measures 7.5 inches. What is the actual distance? Okay, so we have inches here, we have inches here. So we're dealing with 1.5. And this time I'm not going to put the labels there. 1.5 over 60 is the same as 7.5 over our mystery. Cross multiply. 60 times 7.5 equals 450. So we have 1.5 times x is equal to 450. And now I take that 450, again, an equation like any other, divide by 1.5, divide by 1.5, I get x is equal to 300. So it's 300 miles between Pittsburgh and Philadelphia. Okay.